Hey, I've worked in the games industry for about 5 years now on, wow, a lot of projects, maybe over 20 different projects, about half of them indie, about half of them AAA, and I've learned a lot of lessons along the way. And I was thinking maybe I should make each one of these its own video. It certainly could be. However, I thought I'd squeeze it all down into one super compressed video of sort of my top tips and lessons learned from the games industry. Sort of generic stuff that could be applied to almost everyone. So the first one is he who ships wins. There is so much focus on shipping first. This idea that the dating market, Tinder is dominating because they were the first there, at least in mobile. However, when it comes to video games, so much stuff gets canceled. My project for NCSoft got canceled. My project for Facebook got canceled. All these games are getting canceled. What matters more is that it actually gets out the door. Because if you don't have anything to show in your portfolio or something like that, that could really be a bigger concern than having an amazing piece versus an okay piece. An amazing piece is great. An okay piece is okay. But no piece sucks, right? It's better that you have something to show at all. So I think at the end of the day, when it comes to getting the game in a player's hands, just make sure you ship, especially if you're working on an indie game. There's so many indie projects that get started but never get finished. It's okay if it's not perfect. It's better that it gets out and that it exists at all. So that's the first one. He who ships wins. There's another, or in other words, he who doesn't ship definitely loses. So the other thing is, how do you know if you're good or bad at your job? This is something that I was thinking about more. I mean, as my career has matured a little bit, it's less of a concern about breaking into the industry, which is something I was really focused on earlier. And now I'm worried about, okay, if I get on a career, if I get on a contract, how do I know if this job is a good fit for me? And how do I know if I'm really performing well? How do I know if I'm good at my job? Here's something that you can use to identify a bad job. A bad job, in my opinion, is a job where your skills won't change. There are tasks you can imagine where you're not going to get anything out of them, and it's sort of rote. Right? So for example, you might just be debugging something and, you're practicing debugging, but if you've already worked in the system for a while, you're probably not growing as an engineer as a result of it. So that's the first thing I'd worried about. If my skills won't grow. The next thing is if the product won't grow. So if the game is sort of at a dead state, or it's on ice, it's in stasis, you're maintaining these updates as a remote office in India where all the cool kids in the United States are doing the new stuff, that it can be a situation where it's like you're not going to grow as much if the product is not growing as much. I think that's a huge factor. I think when you're working on a product that's like a rocket ship, like Fortnite when it first switched over to Battle Royale, that's an amazing opportunity for career growth in lockstep with product growth. I think you're going to be the product is going to be facing some tough challenges, which are going to present tough challenges to your job function. And I think that's a really great opportunity for you to grow. So I think if you're seeing the product's not growing, it's probably a good indicator that the skills are not going to grow as well. Okay, and the last thing is if you're not going to have impact. So I think a bad job is a job where at the end of the day, if you work your goddamn hardest versus you don't work at all, if you don't show up, you don't notice a difference. That I think can be so demoralizing because as people who are working on something big, we want to see our impact. We want to be able to point to something and say, I fixed that bug or that feature. I created that. I work with those people to get that out the door. If you feel like you're not making an impact on the product, regardless of if it's scaling fast or if it's on ice, you're not going to feel like this is a good job for you to grow. So those are three things I would look at and that I've sort of decanted from different conversations with people. And this was a really good piece of advice I got from, I think it was Billy Brommer from Fortnite. When I was working with him, I had a conversation with him and I said, how do I know when I'm good? And I think to paraphrase pretty considerably from what he said, which is probably a lot more poetic, I would like to say, can you imagine Superman shaking somebody's hand? I think I've seen it in a movie. It's sort of an exciting moment because Superman, Clark Kent, disguised as Clark Kent, he doesn't want to give away that he's Superman. He can't shake this guy's hand too hard. If he does, he'll crush the guy's hand. But on the other hand, mind the pun, you don't want to have a flaccid hand, right? You don't want to give him a wet dick handshake. That's going to be terrible for for the guy's perception of how manly he is, right? He's got to give a firm handshake, yet not too hard that he crushes and kills the guy, right? So that experience of knowing you have the power to just command a problem if it's faced into you. You know, you could crush this problem to bones, to blood, if you needed to. You know that if you needed to create a text serializer or a debugging engine or I don't know, a cool special effect, you know that you could do it perfectly. That you could squeeze the problem so tight, all the blood and bone would be squished out and you'd be left with nothing at all. You feel like Superman. And instead of focusing on how to address the problem because you don't know how, it's a focus of how do I adjust the problem because I know the full extent of the possibility space, and I instead need to decide, you know, just how much does it need to get done? Do I need to squeeze this guy's hand till the point he dies? No, not really. I need to solve this problem to the extent that we could get it out the door, or to the extent that it passes gold certification on PS4, to the extent that we don't have this frame hitch. So if you can understand what I'm saying here, it's you're no longer at a state where you are trying to figure out if I can solve the problem. That's when you know you're doing good at your job. You're not worried about can I solve the problem. Instead, you're worried about how can I solve the problem in the most efficient way possible given the constraints of the scenario. So I think that is sort of a really key metric for figuring out how good you are with respect to your job. And when you feel like you could tackle each problem where you're not learning something, you don't have to worry about how do I do this, it's just to what extent do I do this, then I think that that's a good time for you to get hungry and pull on some more challenges, some new challenges. Okay, cool. And now 4 counterintuitive lessons that I learned in the last 5 years. The first is that when you're working in, this is very specific to working in a big project, but when I was working on Fortnite recently, which is a AAA game, they have this unique way of working, which is that you've got your tasks in different priorities. So you've got priority 1, that's the most important. Priority 2, the least important. The second to least important, and then priority 3 is sort of the back burner. And when we go on a sprint, the focus is for you to actually do priority 3s first, which is pretty counterintuitive, but I've heard it's pretty common in the games industry for you to approach your sprints like this, which is that you want to do the stuff that when shit hits the fan, you've only got 1 day left. Well, you're going to be focusing at that point on your priority 1s. And it's important for your priority 3s to get any attention at all, for them to be the first ones on your plate. So I found that pretty counterintuitive. I would think, oh, you know, at the start of a sprint, I'll get working on what's most important. However, it's actually the opposite. You want to get started on what you probably wouldn't have paid attention to at all. Put, you know, a day or 2 into that. Then you go into the stuff that's a little bit more important. And then as you're driving to the remainder of that sprint, that's when you really focus on the big tasks. And the reason why is because you could play with a little bit of dark magic here with the producers and the production schedule, where it's like if you need to extend and work into the next sprint on a certain task, you're probably only going to get that priority approval if you're working on something that's a P1. Because if it's a P3 and you're like, oh, you know, I kind of want to finish working on this thing that's like a little shitty thing that nobody gives a shit about, they're not going to give you that approval if it's P3, right? They're only going to do that if it's P1. So very specific, very counterintuitive, but it's kind of an important lesson for me. May not be an important lesson for you, but it was an important lesson for me to conceptualize that. The next thing, this is so counterintuitive, but it's important sometimes to let your subordinates fail. I know, it sounds weird. You would think if these people are reporting to me, if I'm managing them, I want them to succeed. But often it's the case. It's better for their career. Sometimes it's not always better for the project, but it's often better for their career for you to let them fail sometimes. For example, I was working on this project where I had some tasks, and I knew that my subordinates were not up for the challenge. They could not have completed these tasks on their own to the level that I needed them at. However, what I decided to do was do the tasks myself. I didn't delegate that work. But I should have, because, well, for one, how are they going to learn if they're not working on these really tough problems? I didn't have the time to expend to that, but if I did, it would have been a way better situation if they had tried to do the problem, failed, then we could have looked at their work together, examined where they fell short, and then addressed how to fix the problem, and then at that point it could have been a handoff to me, or I could have helped them, hopefully all the way through, to progress to the level that I needed it, right? And some tasks are like so beyond the ability of the subordinate that it's like, it's not worth delegating because he's just going to fuck it up, right? But on the other hand, it's like, oh, I actually need you to do this. And if you screw up, that's okay, because I also need you to learn, and I need you to muscle, to build your muscles up so that when you do face a really hard problem and I don't have the bandwidth to step on it, well, then I can give it to you and I know you're going to knock it out of the park. So I think it's a tough game, right? You need to weigh the deliverables and the deadlines versus the progression and the learning of your subordinates. But it's important sometimes to let those subordinates fail so that they can grow for the betterment of the product, for the betterment of the team, even if it's for a short time loss. Pretty counterintuitive, but I think it's really important to get that across. And it's really affected how I manage and my delegation and how I look at that problem. Okay, so the other thing is pretty counterintuitive. Probably the most counterintuitive thing I learned from... Oh, I got a call. I'll call you back. The most counterintuitive thing I learned, which is that, man, when we went to college, we got this railed into our skulls. This idea that at the end of the day, big O notation is what matters, right? This is space-time complexity, often referred to as big O, where you have the big O, which is the worst time complexity or worst space complexity, and then you've got omega, which is the expectation or the lower bound, and then you've got the average, which I think is a phi or something. And so, but often they just say big O, right? Because we want to know what's the worst case situation. However, oftentimes that doesn't matter. And it's pretty counterintuitive, but the most important thing, almost always, is not is not space complexity. It's not time complexity. It's a third axis, which I think we should be teaching our students more in university, which is time to implement. Okay? In other words, you could look at this algorithm and you could say, how fast is it? Oh, it's n squared. How much space does it take up? Oh, it takes log n. Okay. And this algorithm, how fast is it to code? And it might be like, oh, he could get it done in, whatever the metric is. Maybe it's 1 hour of coding, or maybe, you're using like three, what do they call it? 3 weights or however they do all this, agile shit. So you're like, okay, that is actually a much more important thing for me to think about, because sometimes it's better to go with an algorithm that's less efficient if it means getting it done faster, especially because in video games, we work in such a creative environment. It's such a fast-paced environment. Things are being flipped all the time. We might be prototyping, and it doesn't make sense for you to optimize early, right? It kind of leads into this idea of you don't want to over-optimize or early optimize, because it often makes sense for you to do that shitty algorithm and keep it in until it's a problem. I mean, don't code bad, right? And if you're making, certain assumptions and stuff, you want to put that in comments so that you remember what the hell's going on when you come back to this code. But it's really important for you to not focus so much on the big O notation. And I think the interview process really puts a reliance on this too much. As I learned it in university, it's way too much focused on that. It's a big difference between computer science and software engineering. Computer scientists don't give a shit how fast it is to implement. Software engineering, that's the only thing that matters. Because here's the deal. That's what they're paying you for, and that's what we're going to have to pay for when we're worried about how much is this product going to cost, when is this product going to ship. If it takes a little extra second to load, in the vast majority of cases, it's not going to matter. The Pareto principle, 80-20 principle certainly applies in game development, because we've got our main tick cycle, our update loop that you're going to be hitting 80% of the time. Every goddamn frame, you're going to be hitting this update loop. And then every now and then we have this like exceptional programming where it might only happen if you push a button or if you kill an enemy. And it's not every frame. It's like every 1,000 frames or like every few seconds. That stuff probably doesn't need to be that fast. And it doesn't make sense to optimize that at the level of what you're going to be updating in your main update loop. Okay, pretty counterintuitive, but often time to implement matters way more than space-time complexity, which is not taught in schools, but I think it's an important lesson. Okay, and that ties into sort of the last point, which is that sometimes shitty fast is better than good slow. And I think that's almost always in game development, particularly in the prototyping phase, but shitty fast it ties back to the very first lesson I talked about, which is he who ships wins. It's better for us to get it out there, for us to evaluate it on a game feel level, see if it's fun, see if this is working, from a really wide perspective before we worry about getting it fast. So if I could summarize all of that, it would be shitty fast is very often better than good slow. So just another thing to keep in mind. Okay, so I wanted to make this video for so long. There's so many lessons in there, and I could talk about each one, as you could probably tell, for hours. But we're already at 15 minutes. I wanted to hear what are some lessons you learned in the process of game development. And I would love to hear if there's any lessons which you think are in that ilk of counterintuitive. It's not what they're teaching right now in university or in these, these game vocational programs. This is something that you sort of had to learn on the job. I'd love to hear those lessons because I feel like it's sort of that counterintuitive stuff that is often the most important for us to remind ourselves of, because if we don't sort of analyze those lessons, we'll take for granted the more intuitive solution, which is not always correct. So I'd love to hear what you think. Like this video if you liked it, subscribe if you want more, and I will see you guys in the next one.